You're watching Singularity Net, and this is Decentralized Future, part of the Decentralized OS web series. My name is Luke Robert Mason, and I'm the host of the Futures podcast, where we meet the scientists, technologists, artists, and philosophers working to imagine the sorts of developments that might dramatically alter what it means to be human. You can check out my channel using the link in the description below. Now, Laurence Moroney has a unique understanding of how machine learning and artificial intelligence will transform industries, careers, businesses, and society at large. As the lead of AI developer relations at Google, he's been at the forefront of thinking about how best to train coders with the skills required to master ML and AI. Ultimately, he sees the future as one where these skills are democratized and where coders have the best resources to leverage ML and AI for the greatest good. So Laurence, for anyone not familiar with machine learning, what is it and how is it different from artificial intelligence?
It's a great question, and you could probably ask 10 different people and get 10 different answers.
Or if
you're a programmer, or if you're a programmer, you ask 10 different people and you get 10 different answers. So how I look at it is machine learning is really just a new programming paradigm. It's really just a new way for you to code to solve problems. There's nothing magical about it. There's no pixie dust. It's just like this. Usually when you try to solve a problem in coding, you're writing a lot of rules. If this, then that. If this, then that. Else this, else whatever. The idea with machine learning is that instead of you trying to figure out all of these rules to solve a problem for yourself, you get a lot of data and you label that data that already solves the problem, and you have a computer figure out, what is it that matches this data to this label. And that sounds a little bit abstract. So let me give you an example. Like, say you want to build like a computer vision thing that can tell the difference between a cat and a dog. And so if you were to show it a picture of a cat, then it kind of would roughly guess that this is a cat. Show it a picture of a dog, roughly guess this is a dog. Now, if you're trying to write if-then rules for that, how would you do that? Right? Like what pixels would you look at and what color values? And you could just imagine you have to write millions and millions of lines of code. But when you do machine learning, the idea is like, well, what if I get a few thousand pictures of cats and a few thousand pictures of dogs, and I tell a computer, this is a cat, this is a dog, and then I write code using the machine learning paradigm that matches those labels of cat and dog to the pixels in those images. And now this will end up creating something called a model. And then if I throw an image of a cat at the model, it'll come back to me and say, I think this is a cat, or I think this is a dog, those kind of things. So instead of you writing millions of if-then lines of code to be able to do that, you write a few hundred lines of neural network code or convolution code or these kind of things to be able to train a computer to be able to do that pattern matching. And that's ultimately for me what machine learning is you're writing a different type of code. It's a new coding paradigm so that you'll train models to be able to determine some of these things that you normally would have to write tons of lines of code to do. Now, what has that got to do with artificial intelligence, you might ask? Is that, well, that the idea behind that is that then empowers computers to act intelligently. Like I just mentioned, computer vision. So a computer to be able to recognize images is now kind of emulating what a human does, right? When we look at a picture and we say that's a cat or that's a dog, or if it's able to recognize sounds, or if it's able to recognize activity, and it's behaving intelligently. It hasn't magically become intelligent and self-aware or anything like that, but the way that it behaves is more like the way a human would behave. Like if I showed you a picture of a cat and I showed you a picture of a dog and I asked you to say, well, which one is the cat? You point at the cat, but why would you pick the one that's a cat? What is it that you would say that picture is a cat?
It's not a dog. I mean, that would be a good start.
But it might be things like, cats have these distinctive pointy ears, or they have like distinctive eyes and those kind of things. And you'd pattern match and you'd say, like, when I see those pointy ears and I see those eyes, that's a cat. And if I see a tongue hanging out, that kind of thing.
Which one looks more evil is usually the case. So which one looks more evil? That's the cat. Yeah.
Which one is plotting to murder you and which one loves you? Unfortunately, that's not represented represented in the visuals, but yeah, I totally agree with you. But yeah, so the idea is like, you kind of like look at those things and, you can call them features, and those are features of a cat or features of a dog. And in your brain, you're then pattern matching to say, well, when I see these features, it's probably a cat. And if I see these features, it's probably a dog. And, it's exactly the same thing that the computer would be doing when you program something called a convolutional neural network, is that it learns to extract and spot features and then matches those features to things. So it's kind of acting the way that you would. But what's fascinating with it in the computer sense is that, well, when computers see things and they learn features like this, they might actually see features in images that you and I don't see, but they will consistently see those features and determine, hey, these features make this a cat or make this a dog. And when people have visualized those, you've probably heard of things like deep dream and all of that kind of stuff. And it's like you see like these weird kind of psychedelic images. And that's when people wrote a visualization to say, this is how the computer sees the thing. And it's kind of cool to kind of, look inside the computer's brain, as it were, to say, okay, when it's interpreting something as a cat or a dog, this is actually what it's seeing, and that type of thing. But ultimately, that's the idea. Machine learning is your programming paradigm that will help you to write applications that respond intelligently, and therefore put the word artificial into the artificial intelligence.
I mean, we hear a lot of hype about artificial intelligence and machine learning and what it's able to do, but what does that ecosystem actually look like at the beginning of the 21st century?
Another great question, and I think we're still in the hype cycle. And so if you're familiar with the Gartner hype cycle, you got this great big peak at the beginning called the peak of inflated expectations. And then it falls into a trough, which is the trough of disillusionment. And then once you're in the trough of disillusionment, you can slowly climb out, into the plateau of productivity. And I know it sounds like the Lord of the Rings or something, right? That kind of thing, this cool map that you're going to go through. And I always joke that it's really my job to get you to tunnel through the peak of inflated expectations into the trough of disillusionment. So yes, I actually get paid to disillusion people. So first of all, so like in the outside world, outside of just the core people working in AI and ML, there's still so much in the hype cycle. And the interesting thing about the hype cycle is there can be a negative hype cycle as well as a positive one. But the point is, it's like there's a lot of confusion and people just don't really know what this is all about and buying into the hype cycle, either being terrified of it or overselling it. This will solve all your problems. Sprinkle AI magic pixie dust and all your problems will be solved. And the point is to blow through that and get into what's called the trough of disillusionment. And once you're in there, that's really productive, because then you begin to know, okay, this is what this thing actually does for real. I don't need to be scared of it. I also don't need to be somebody who's bought into a hype to say that this can do everything, and I can start to solve real problems with it. Now that I know what it is, and I joke that it's my job to quantum tunnel people through that peak into the trough of disillusionment. But once they're there, that's when they can really start doing the really cool stuff that changes the world.
Well, you seem to have a lot of job titles at Google. You're the lead in disillusion and quantum tunneling, Laurence. I mean, the crazy thing is a lot of people still get excited about AI and ML, but the question is, how do we actually train and educate people with the skills to build futures whereby these two things are going to be so important? So how do we get folks familiar with the skills that they need to be masters at ML?
Right. So I think there's two main skill sets that we need to think about. So the first one is creating the models, and then the second one is deploying and using the models. So I'll start with the creating the models part, which is where all of the industry is talking at the moment and all of the good stuff is happening. And you'll often see training courses for these kind of things that bring you back to your high school calculus or your college calculus, and it might scare you off. So I say, don't be scared off by those, because as companies like Google are producing frameworks for building AI solutions, we have one called TensorFlow. The idea is to abstract away all of that complex math and to help you be a coder to build these things. So then the one skill that you need is to be a coder. And the one skill in coding is a language called Python. And so I would definitely say if you want to get into model building, before you think about anything about machine learning or AI or any of that kind of stuff, learn Python, learn basic programming. You don't need to be an expert with years of experience. I only had a few months experience using Python when I started in this role, that kind of stuff. And the nice thing is that it's a super easy language to learn. And so I'd say that would be the very first thing. Before you can begin, try that, take a look at Python, learn it, play with it, and then start looking then at some of the frameworks, like our one is called TensorFlow. And the courses that I teach on Coursera and Harvard and a few other places like that. I'm always like, don't worry about the math. If you're learning AI and ML and you're seeing Greek letters, take a step back and let's look at it in code. And I'll teach in code first and show here's how a machine learns, and show that in code, and so that you don't really need to be afraid of it. And it is very approachable, and it's actually become, because of all these high level APIs, it's actually become quite easy to do because a lot of that complexity is abstracted away from you. So I'd say that's the first thing. The second one then is for people who are deploying AI. So if you are already a developer on a top deployment platform like iOS for building iPhone applications, or Android applications, for running on Android phones, or web applications that run in the browser, then you need to learn the skills of how to interface a model to your work. So we create a framework called TensorFlow, and the clue is in the name, that when you have a model, your flow tensors in and your flow tensors right out again. And but if you're like an iOS developer programming in Swift, you don't even know what a tensor is. And how do I get my image into a model and convert it into tensors? And how do I parse the thing coming out of the model as tensors to say this is a cat or a dog? Those kind of things. So it's those kind of skills to be able to bridge them. If you're in that part of the world, if you want to build apps that use machine learning models, would be the next thing to learn. And that's actually what I'm focusing on this year. For the last couple of years at Google, I've been focusing on the model maker community, but now I'm really focusing on the deployment community. I'm writing a book on it at the moment. I'm going to be doing a bunch of talks and videos about that in the coming year, because I think, that's an important growth area.
I mean, what is it that makes an effective syllabus for developers? You said that you've written a couple of books on this sort of stuff. So, how is the best way to design a course to teach people these skills?
So I like to kind of start it simple, start it just as the simplest possible thing you can do, the simplest hello world type thing that you can do, and then use that to show the bigger skeleton that's hiding under the surface. If you've ever learned, there was a famous book, I'm trying to remember the author now, but one of the famous books on C++, when I had to learn that many, many years ago, and he just kind of showed you 20 pages of writing and code that kind of printed hello world on the screen. And, it was oh my gosh, you have to do all this kind of thing to do hello world. But once you've done that and you have hello world printed on the screen, and then you understand how files are linked to each other and how the compiler works and what header files and blah, 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 all that was. And that kind of blew my mind, that was wow, he only taught me how to do hello world, but the underlying skeleton was there. I tried to do something similar, at least to get people started with TensorFlow and machine learning. Fortunately, it's not 20 pages, it's only a few minutes. And it's I give them two sets of numbers, and there's a relationship between these numbers where y equal, this is the one bit of math I do, y equals 2x minus 1. If I give you a bunch of y's and I give you a bunch of x's, and there's that relationship. And then I show you in about 3 lines of code how to build a neural network that doesn't know what that relationship is, but learns that relationship. And then with those 3 lines of code to learn that relationship, now suddenly this cracks open your mind so you can realize when we talk about a computer learning, this is what it's actually doing. It's not really learning. It's making lots of guesses. It's measuring how good those guesses are. And then it's optimizing those guesses and then repeating that again and again and again and again until the guesses get better. So technically, you could say it learns. And then once you do that, I find that breaks the ice. People begin to see how a machine can learn. And then I'll just start layering in more and more advanced concepts as they go. And then once they've kind of gotten to a certain level where they're now quite competent in machine learning and Python, then for me, when I teach it, there's three core areas in machine learning that employers are looking for right now. One of them is image classification, being able to do computer vision to recognize cats and dogs, like I spoke about earlier on. One of them is natural language processing, to be able to understand sentiment in text. So, to classify text, if it's maybe toxic or not toxic, or spam or not spam, those kind of things. And then the third one is sequence modeling. So to understand, like, if data is in a sequence, like maybe weather patterns, to predict the next day or to predict the next elements in that sequence. So I'll then go into those three after that. And then I think once somebody has done those four, like that foundation plus those three, then they have a pretty decent grounding in machine learning and being a machine learning model creator.
I mean, what are some of the challenges that you find with trying to get coders to become machine learning or AI developers? Are there some sticking points with how they have to change their thinking?
I think the biggest thing is the fear, to be honest, or the imposter syndrome. That the imposter syndrome is like, I believe I can't do this. I'm not good enough to do this. And I think a lot of the imposter syndrome has come about because of the hype. And so I was talking about the hype cycle earlier and trying to bust through that. And then maybe a lot of the rest of it is that until relatively recently, AI and machine learning were very academic principles as opposed to industrial or commercial. And as a result, the academic stuff, is like, go read this paper to solve a problem. And then you read the paper and it's like 20 pages long and full of Greek letters, that turns a lot of people off. And those generally are the things that I've encountered that turn people off the most. And also developers, we tend to be pragmatic, that we want to get to a solution quickly, even if it's not the complete solution. So helping being able to build something that gets a developer to a situation quickly, to a solution quickly, is always a challenge, and can be more so a challenge in machine learning because there's all these new concepts that you have to learn before you can get to the solution. So managing expectations around that is probably the other big challenge.
I mean, one of the ways that you train some of these developers is through MOOCs. I mean, I just wondered your thoughts on MOOCs and how they've really transformed online education and made the learning of AI skills possible.
That's a great question. And that's the one that I've been staggered at how successful it has been. And I'm trying to figure out exactly why. I think one of the reasons why is a well-structured MOOC isn't just somebody on your screen talking to you. And so we've been very careful about, it's not just a video of me presenting slides and saying blah, 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 but to kind of teach a concept and then have the person practice the concept. Well, sorry, I beg your pardon. I'll teach the concept and then I'll show the concept and then I'll have somebody practice the concept. So, for example, I'll have a video of me saying, this is what a convolution is and how a convolution works. And then I've written some code for a convolution, what it is and how it works. And then I'll screencast me showing the code. And then I'll say, okay, here's the code. Go for it yourself. And, as humans, sometimes we need to hear something multiple times before it sinks in. But if we hear it multiple times in the same way, you get bored. So it's to try and kind of do it that way. And I think it's one of the things that's led to the MOOCs being quite successful is going with that approach and always, always, always having code. I've come from a developer background, and I have to say, as a developer, I was incredibly cynical, and I'm sure lots of other developers are. And it's like, hey, this person from big technology company is saying, this is awesome, go do this. I'm like, I'm not going to trust you because you're trying to sell me something. But when they say, hey, this is awesome, go do this, here's the code, try it for yourself. And then I can go in and I can pull that code apart and I can see how it works. Then I begin to build that more trust and I learn how to do the thing. So that's one of the things that I've been careful about doing with MOOCs. And I think that's why MOOCs really work if they're done in that way. Because sometimes in the classroom, if you were to sit in a university and learn like that, the lecturer might be able to show you, right? They'll be talking in front of a whiteboard and they might be able to do a demo of this thing actually working. And then it's like, well, they hand you the code, you're on your own. You got to talk to TAs because they can't scale to be able to deal with you and that kind of thing. So I found that's something that's just worked very, very well for me.
It seems like what you're trying to do, Laurence, is really just make AI easy. So why is it important to just make this stuff as easy and as accessible as possible?
It's funny that you said that, because one of the things we have at Google is like we have an internal web page that everybody has called our Teams page. And on your Teams page, you write a 3-word mission for yourself. Your mission can only be in 3 words. And my 3-word mission is make AI easy. So it's funny that you said that.
As opposed to don't be evil. Okay.
No comment. So mine is make AI easy. And even though that's technically 4 words, but don't tell anybody. So I think the key to making AI easy, and why I want to do it is, I mean, if you think back to the 90s, like AI, or even in the 80s, late 80s, early 90s, AI was all the rage for a while. And then it froze, and we had what's called the AI winter. And it's only relatively recently that we've been coming out of the AI winter, and now we're in the AI spring. And beginning to sound very Game of Thrones here, but the idea there was that if you look back to that, AI was in the hands of very few people. Because it required a lot of computational resources. And like in the late 80s, early 90s, most of us didn't have a PC right on our desk or a laptop. And our phones now are more powerful than the supercomputers were back then. So very few people had the compute power to do it. And it was a very academic thing. It was very much, here's how to do an algorithm that learns this better than that other algorithm. But it wasn't easy to put that into use in industry, because people were writing stuff in industry in languages like Visual Basic, and just Visual Basic and AI. There was nothing. And as a result, the academic interest eventually dried up. We had the AI winter, and we've only recently come out of that. But how to avoid that happening again is to just really explode the usage of it by making it easy for the average person to use it. You know, we can't use the excuse anymore that the compute power isn't available, because it is, and it's cheap. We can't use the excuse anymore that the data isn't available, because it is, and it's cheap or free. And now it's just a case of, okay, skill sets. Though that would be the one blocker in doing it. If we want AI to be, usable by anybody, so any consumer to take advantage of AI products, and any developer to have it easy to build AI products, then the last thing that's like needed, the last block that needs to be knocked down, is the skill set block. And that's what I've been very much focused on.
You mentioned the consumers there, but let's think about the employers even for a second, because it feels like everybody is desperate to find good AI talent. Even SingularityNet is constantly on the hunt to find the next big hotshots in AI development. So where do you believe employers can go to discover that AI talent?
So that's one project I've actually been working on, and that is, earlier I mentioned there were 3 main skills that employers are looking for in general. It's computer vision, natural language processing, and sequence modeling. Most jobs, if you take a look at them, that are trying to hire an AI person, are doing one or more of those. And so at Google, we launched a TensorFlow certificate program where coders can go and do an exam, and this exam tests them in those 3 scenarios, that they actually have to create models and train models and send those models to us. And, we will then test those models to see how good they are or how bad they are. Like, maybe it's like, I've been talking about dog and cat like a lot, but it could be, for example, like they get, that they have to train a model to tell the difference between the 2, and they send it to us, and we throw a bunch of pictures of dogs and cats at it. And if they get a lot of them wrong, sorry, your model's not very good. So like those kind of things, there are lots of scenarios like that, but those 3 core things. And at the end of that, if somebody passes that, then they get like our developer certificate. So I think that will be one of the first things that we're trying to do to help employers, as well as training millions of people. We're also kind of saying, okay, people can go to a MOOC and they can maybe not pay attention, and they can get a completion or those kind of things. That doesn't mean they're necessarily employable. But if they've done these rigorous tests and they've passed these rigorous tests, then they're something that will help you, as an employer, find good people. So we maintain then a directory of the people who've passed the test. And also, if you're a job seeker, then it's a great way for you to go to an employer and show, hey, I know this stuff. And there's one other disconnect is we've seen that often employers who are looking for AI skills don't have AI skills to begin with, so they don't even know the right questions to ask. I've heard nightmare scenarios of people like, saying, going for an interview and somebody asking, well, what's the difference between gradient descent and an atom optimizer? And like the person is like, well, I'm a coder. Do I need to know this kind of thing? And even the questioner may not know the difference between the two. They have a piece of paper with the answer on it and hope the person gives the right answer so that they can check it off. So like being able to kind of help employers ask the right questions is also a part of the point of the certificate program.
Mm-hmm. And then I guess on the other side of the equation, if you are a coder, how do you recommend they build their career, especially in the current environment?
Yeah, great question. And I get asked this one a lot. And, I'm very optimistic, despite the current environment, that for coders and developers, because there really has never been a better time. Almost everything that you can use, like the tools that you need to learn, are almost all free. Data for you to be able to build stuff is so widely available from the likes of Google and Kaggle and other places. GitHub is a place that everybody knows about, that you can put your stuff and show it off to the world. There's ways that you can share via social media. There's blogging platforms like Medium and all of these kind of things. And, when I was first trying to get out into the industry, it was really hard to get a job interview because there was no way that like I could show people what I'd done. I could tell them on my resume that I've done blah, 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 but you do enough of that in your resume, it soon gets boring to read and you got to find that sweet spot. But nowadays it's like, if I really would like a job as an AI developer, I can download TensorFlow, it's free. I can use Google Colab in the cloud, which gives me GPUs that I can use in my browser for free. I can write this code, take learning courses for free. I can publish this and host it on GitHub for free. And, there's all of these kind of things that I can do to get myself out there that, weren't really available not that long ago. So I know despite the pandemic and not a lot of people are hiring and all of these kind of things that, but we will come out of that. We are already, I think, coming out of that. And when hiring opens again, it's going to be floodgates. And wouldn't it be good to use this time to be ready when that opens again? And there's no and that'd be harsh for me to say there's no excuse, but there's no blockers in the sense of you have to buy this or you need to afford that, because it's all freely available.
Now, I know another thing that you're really passionate about beyond education is the idea of democratizing machine learning. So what do you mean by that, to democratize machine learning? And also, what are some of the tools that are enabling this democratization?
Right. So, in its simplest sense, it just means the more people who know about it, the better we will be on the whole as a society in dealing with it. Mm-hmm. If it's in the hands of a select few, billionaire companies in Silicon Valley, or just that kind of select few, it doesn't help everybody. I think the more people who are exposed to it and who understand it and who can use it is the first thing to be able to make it better and make the world a better place for everybody else. So, I like to share some examples of things that people have done that's very non-traditional. So, like Tanzania in Africa, there are farmers in Tanzania who grow a crop called cassava. And the cassava plot is primarily grown as their backup crop. So the idea is that they grow a cash crop, and when they have that cash crop, they can sell the cash crop to send their kids to school, to put food on the table and all those kind of things. But if their cash crop fails, they don't want to starve to death. So cassava is their backup crop. But if cassava fails, like any good engineer, if your backup fails, you're really doomed, right? But one of the problems with cassava is that it's very susceptible to blight. And once you've spotted blight in one of your cassava plants, you basically have to throw everything away. So here's where machine learning was like being able to be used, running on an Android device, not connected to the cloud, a cheap Android phone, where some folks in Tanzania partnered with a university in the US to take pictures of cassava plants over time. And then it was like, then take pictures of the same plant later when it was blighted to see, can a computer spot the blight in the plants before a human would? And the answer to that was yes, it could. And out of that, then they were able to build an app that with this app, now a farmer can put this app on their phone. They don't need internet connectivity. It all runs locally on the phone, take a photo of their plant and determine that it's blighted before the human eye could do so. And as a result, if that plant is blighted, then you can rip that plant out, throw that one away, but not necessarily lose your whole crop. But it was like people in that environment, knowing that this was possible through the democratization of the education of AI, brought about that solution. But if the education of AI was only in the hands of folks in the ivory tower who don't care about cassava, who probably never even heard of cassava, I know I didn't before I heard of this story, then that kind of solution just doesn't become possible. So when I talk about the democratization of AI, that's one part of it, is like make everybody have equal access to it by lowering the bar of access as much as possible. And that's why I say the framework is free, the tools to be able to build it is free, the data is freely available, the skills for learning it are, you can find them for free. Sometimes you have to buy a book, but sometimes you can find them online for free. Things like Coursera courses, I chose to teach at Coursera because even though they have a paid model, they also have a free model where people can audit the courses and get them for free. And that, to me, is the more people's hands it's in who are able to do stuff with it, that's the beginning of democratizing it. And I think we're already beginning to see some great results from that.
I'm fascinated to learn more about how Google are helping some of that democratization as well. What are some of the case studies that you're directly working on with the folks over at Google?
Yeah, so I mean, that was one of them that I mentioned, the cassava. Mm-hmm. We ended up being involved in that one. There's lots of others that I would say the easiest thing probably to do is to go to our YouTube channel. So it's youtube.com/TensorFlow. And we have a bunch of stories there of stuff that was made with TensorFlow. But the important thing about it is many of these stories were not stuff that was built by AI experts. It was stuff built by people who are experts in a particular field, and by us making AI easy for them, they could apply that in their field. So there's a lot of stuff in medicine. There's one in apparently for creating antibiotics. I'm not a person who understands this stuff. I'm more the AI guy, but a lot of times when you create antibiotics, you have to do a lot of testing. You've got a lot of Petri dishes where you put a sample of your antibiotic and a sample of the biotic that you're trying to kill, and then you measure how that works. It's a very time-consuming process, but apparently the same kind of computer vision algorithms that I spoke about with cassava could be applied there and can really speed up the creation of antibiotics. And that case study is actually on our site. There's another one that's a personal favorite of mine. Is there's a young man from Mexico who was an expert in Mexican music and understanding Mexican music, and he developed this very finely tuned ear for detecting different sounds. And he ended up being hired in oceanography, and using his ear, he could detect whale sounds in the ocean. And he could pick them out from background noise amazingly well. And he worked with Google to then create a machine learning model based on his experience. He hears you record a piece of sound and he hears a whale in it. None of the rest of us can hear a whale in it, but he would label, there's a whale here, there's not a whale here, there's a whale here, there's not a whale there. And out of that, a model was detected, and it's used in the Pacific, I'm trying to remember the name of the town, south of San Jose in California, where there's a research institute there, and they can actually track whale populations just by plunging microphones into the ocean. And again, this was a guy who wasn't an AI expert, he wasn't an AI engineer, but he knew sound. And the concept of the democratization of AI then allows him to build a solution that can be used in those ways. And there's tons of stories like that. And I would say just go to our website and you can have fun with them.
Well, it feels like, with the example you've just given there, that the real way to unlock the power of machine learning is to find ways for domain experts and industry experts to collaborate with developers. So how do we create more space for that sort of co-collaboration to occur? So
I think the one thing is to have more developers, right? That, when there are relatively few developers, it also makes them very expensive. So the idea is if you have more and more developers who could, if you have more and more developers who can do this, then it's a case of they're not rare and hard to find. And then there are opportunities for these domain experts to collaborate with them. So it's my goal to train millions of developers. When I started this journey, and what influenced me to do this journey was that I read a research report that there were 300,000 AI practitioners in the world. And this is about 5 years ago. And it's about 100,000 in the US, about 100,000 in China, and about 100,000 in the rest of the world. And then I was like, okay, what's an AI practitioner? If there's only 300,000 of them, how do you measure them? And the only way that they could measure them was that these were people who'd had their names on a research paper. And I was like, okay, so now the industry is saying to be an AI practitioner, you need to have your name on a research paper. I don't have my name on any research papers, so by definition, I'm not an AI practitioner. And I saw there was an opportunity there that, like, depending on various different surveys, there's usually about 30 million software developers or more. And I was like, well, if you can get 10% of those 30 million software developers to understand machine learning and to be able to do machine learning, you'll increase the number of AI practitioners globally by 10. You'll go from 300,000 to 3 million. And, so there's definitely something there if you only reach 10% of them. And I think, it's become such a valuable skill that we'll probably reach more than 10%. So that became the driving focus for this. That became the driving mission. And then as a result, now we're training millions of developers. We've already reached that point. Maybe not 10 million yet, but we're in the millions. And so the idea then is that as millions of developers are coming online and they have the skills for this, then they can pair up with domain experts, and who knows what they'll come up with. We don't want a world where to build the cassava solution or the antibiotic solution or the whale song solution, you need to work with Google. I want a world where when somebody wants to build a solution like that, that they can go to a local meetup and find 20 developers who know this stuff that they can partner with, and we have nothing to do with it other than enabling them. And it's like once we reach that is what I'm considering to be real democratization, and we're definitely heading there.
I mean, not just democratization, but representation, because what does that 3 million look like? How do we deal with the perceived representation issue in AI, which is often the reason for so much inherent bias within machine learning?
That is a wonderful question. Thank you for asking it. So again, the further you lower the bar of entry, the easier it is for people who are traditionally underrepresented to be represented. So that would be the first thing. So like really what I'm trying to do is drive the barrier of entry as low as possible, and to no gatekeeping, fight imposter syndrome, tunnel people through the hype cycle, and all of those kind of things. People, of course, they have to want to do it, they have to want to join in, but if that bar is as low as possible, then like I said, the traditionally underrepresented groups can be represented. And then secondly is like to understand that there are traditionally underrepresented groups, and a bar that's this high for me might be this high for them, and to try to help, in ways that are possible for them, for us to see if the things that we can do to reduce that bar through scholarships, through mentorship, through various programs that we run for women, for Black in AI, for various underrepresented groups. Like I've recently started working with a university in New Mexico for the Navajo tribe, that kind of thing. That the Navajo folks are the poorest people in the U.S., and the access to technology that they have. I've been talking about the very low bar, like, TensorFlow is free, data is free, Colab to be able to do these things are free. But a lot of these folks don't have a computer, right?
Wow.
I'm assuming that you need a laptop or some kind of a desktop computer to be able to do this. And, how do we, like I said, we're trying to drive the bar here, but for some folks, we have to recognize that it's there. So things that we can do to understand that even the bar is as low as possible, that some people still can't cross it. And how do we get them across that? What can we do? How can we leverage our power to be able to do that? So there's a whole bunch of stuff going on in that area. It's not just writing a check, right? In some ways, writing a check is the weakest part of it. I think there's a lot more that as an industry we need to do. And we're getting involved there. Like I said, scholarships, mentorships, teaching, giving access to hardware, whatnot. And once we've done that, and you have that better representation in the industry, then the kind of biases that you mentioned, bias is always going to be present. Bias has always been present, but at least it will help us combat that bias. And I'm generally very outspoken that it's really interesting that in the AI and the machine learning space, we talk about bias, but let's be honest, we've always had bias. Any kind of computer programming language, anything for solving a problem, there's always been bias inherent there. And, you can then engineer to reinforce that bias if you're not careful. It's not just an AI problem.
It feels like the bias that you're referring to is the reason we have so much broken code in our society that often informs how we navigate our digital lives, doesn't it?
Yeah, it can, and I mean, but I think it's even more fundamental than that.
Mm.
I mean, like I always like to give an example that when I say bias has always been with us, that if you're familiar with a language called SQL, structured query language, which is used in databases, that I've seen and I've helped marketing people debug SQL statements that might be along the lines of, "Hey, we want to grow our business in this zip code." So what we're going to do is we're going to go to our database and we're going to select all the customers from that zip code, and we're going to give them like a $10 coupon to spend in our store, or we'll give them a 20% discount to spend in our store. And let's do that. And like in SQL, you just say, select star from customers where zip code equals whatever. Can you see the bias there? Right? It's subtle, but it's there, because it's like, okay, well, if you now look at that zip code, what if 95% of the people who live in that zip code are white? You're now saying that white people are getting a 20% discount, where the zip code next door, where say 80% of the people are black, the black people are not getting the discount. And a simple SQL statement like that, with all of the decisions behind it, can greatly reinforce a bias and provide, in this case, a very material advantage for the people in the zip code who just happen to the majority of them to be white. And it's like, I've seen this like in many, many examples in the real world, and long before anybody was thinking about AI. So there's like all of these kind of things where there's engineered solutions can reinforce bias, can make life easier for some people and more difficult for other people. And it's one of those things that, like, we always have to be cognizant of that when we're engineering solutions. I'm really happy that AI is the thing that finally got us thinking about it, but it's not a fault of AI that this happens, because it's been with us, and that's why the society that we live in is the way that it is today.
And I know another big thing in your life, Laurence, that informs your thinking about AI and tech is science fiction. So I just wondered if you could tell us a little bit about your interest in science fiction and how that's really informed the way in which you think about the possibilities for AI.
So I think when I was a young kid, do you remember the store Woolworths in the UK?
Yes, we had it in the UK, yeah. There's the pick and mix.
Yeah, I guess there's still some Woolworths, but I was in Ireland, and at that time the Woolworths in my hometown was closing down. And I went into the Woolworths in my hometown, and I was looking at books, and there were a whole bunch of books by this guy called Isaac Asimov that were available for like pennies. And I ended up like scooping up a whole bunch of them, and and I think my pocket money for the week would buy me about 20 of these books. So I scooped them up and I read them, and I just fell in love. The how he viewed the world, how he looked at the world. And I think Isaac Asimov was one of the people who primarily shaped how I look at the world. And so that got me absolutely hooked on sci-fi. I wanted to be like Isaac Asimov when I grew up. I wanted to be able to write like him and that kind of stuff. Obviously got involved in sci-fi, watching it on TV, watching movies, all that kind of stuff. But got involved in consulting for a TV show a few years ago called Stargate. And, that really kind of got me, really helped me kind of get into the whole concept of sci-fi. So I ended up writing a few novels, and some of them became like pretty. And I think one of them was a #1 bestseller. I can't remember. And, it's hard nowadays when there's so many places that books get sold, that the idea of a #1 bestseller is kind of been diluted, but it sounds great, and that just got me into the whole sci-fi space. And I kind of want to be a little bit more involved in the sci-fi space. I'm a member of the Sci-Fi Writers of America now, and particularly from the AI perspective, because if you look at any sci-fi, and when AI comes up in sci-fi, it's very much on the Gartner peak of inflated expectations, because AI is always either going to be an excuse for the bad guy. It's hard to find shows where AI is not the antagonist, or it's like the Pinocchio story, like Data in Star Trek, like that kind of thing. And there's just so much more that can be done in storytelling with AI when creators actually understand what AI is. If I can quantum tunnel them, into the trough of disillusion, so that they can understand that AI is far more mundane in some ways than how they write it and how they create it. But when you understand how mundane it is, then you can start doing interesting things with it. And I see a dearth of that in storytelling at the moment. Although I'll make one exception. There was a brilliant movie, I think it was called Her,
Yep.
It was like Joaquin Phoenix. He had like
Spike
an AI
Jonze.
assistant in his ear.
Uh-huh.
That was brilliant, and not just a brilliant movie, but also in how it portrayed AI. I really like that one. But yeah,
Well,
so
do
that's
you
my
mind me
sci-fi
asking?
stuff.
Do you mind me asking you a little bit more about Spike Jonze's
Yeah.
Her? I mean, what was it about that film that was such a compelling vision for how AI could be imagined?
So I think, first of all, it didn't fall into the realm that I just mentioned, where AI is the antagonist or AI is
Mm-hmm.
Pinocchio. The AI character in this, voiced by Scarlett Johansson, was very real. But what really intrigued me about this was spoilers for the movie for people who haven't seen it. But the idea is that, first of all, if you look at the relationship between him and the AI, first of all, it started like, you're this kind of weird like assistant, like, Google Now or Siri or those kind of things. And then she evolved to be his friend, but then she evolved beyond him. There's one point in the movie where he went away for a weekend in the woods and he was disconnected from her. But then by the time he came back, she had, he'd been away for 2 days, but in her subjective time, it's like she'd lived 1,000 years. So she had like evolved way beyond him. And it was all crafted through the eyes of the friendship between two people. And there was like a symbolism for like two people being lovers, right? First meeting as friends, then becoming couple, then growing apart. But that was kind of worked into the case of like, the relationship between a human and an AI as well. It's first is this mysterious, weird thing in the distance that I don't understand. Then it tunnels through the hype cycle and becomes something that I do understand. And then it grows beyond me in this case, in the story, where it's like, once we understand what it is, then we can see what is possible, what is the potential is with it. And the story kind of showed that in a really, really elegant way. So great movie. And I'm sorry if I've spoiled it for anybody who hasn't watched it yet, but still go and watch it.
Well, the final question I have to ask you, Laurence, because we're filming this for Singularity Net, is what do you think of the idea of decentralized AGI? Not just democratized, but fully decentralized?
Oh, good question. I really need to think about that. I think the first thing whenever somebody says AGI to me, though, is I would ask them to kind of fundamentally rethink what they think that is. There's that meme of the guy from the Princess Bride where he's saying that word does not mean what you think it means. And so whenever somebody says AGI, I always reminded of that meme, because often when people talk about AGI, they talk about an AI responding exactly like a human, behaving like a human, and having the values of a human. But there are so many different forms of intelligence that, you could actually have AGIs that are not at all like a human, but are very intelligent. I was just reading recent research about like an octopus. I don't know if you saw this in the news, but like, the researchers looking at how an octopus was learning was like, in some cases, an octopus was able to pass tests that were designed for a human child. But think about, I hate to say racism about an octopus, but think about how racist that is that you're only acknowledging that it's intelligent because it's passing tests that were designed for a human. That we have that very human focused approach to things. And I say, like, when we come into like talking about AGI, we have to kind of, check that at the door to say, an AGI isn't just passing the test that would be a human. There's many ways to be intelligent, and we haven't really looked into those yet. So to then bring that to the concept of centralization or decentralization, that decentralization might be one of the keys to that, because human intelligence is inherently centralized. It's between our ears up here. But there may be like many, many types of actual intelligence out there, and they could be all around us for all we know. We're not looking for them, that are decentralized. And by exploring decentralized AI and seeing there's like a potential AGI around that, we might actually be able to learn about real decentralized AI that's around us. So I definitely encourage looking into it, but I always say to kind of like remove the human focus, because it's one of the things that almost everything that we do, like the Turing test is another great example of that, right? Is that if the computer behaves like a human, then it's intelligent, and let's be honest, humans aren't particularly intelligent ourselves. So that there's a false concept there that it's good to be reminded of and to actually try to break out of.
Yeah, it's important not to be speciesist. It's important to be a substrate pluralist in many ways. And on that note, I want to thank you for your insights into how to most effectively develop AI. And as always, we want to hear from the SingularityNet audience. Please share your thoughts on this subject in the comments section below. And as always, the conversation continues on the SingularityNet Telegram group and forum. You can follow Laurence's work using the links in the description for this video. And finally, don't forget to subscribe to this YouTube channel and hit the bell to get alerted to all of the upcoming Decentralized OS web series videos. My name is Luke Robert Mason, and you've been watching The Decentralized Future. And on that note, Laurence Moroney, thank you for your time.
Thank you so much, Luke. This has been a blast.